Welcome to Stewart Science. Today we're talking about how to measure. Now, you wouldn't think this is something that you have to teach teenage people or grown adults, but that's okay. That's why I'm here. So we're going to talk about how we use tools to take accurate and precise measurements. If you haven't watched the accuracy and precision video, go back and watch that one. But today on this episode, we're talking about how do we use specifically a ruler to take good observations. So lay down a couple ground rules first. First of all, always start at the 0 mark on the ruler, not the tool's edge. 99% of rulers in America have a little bit of space at the beginning of the ruler, and then the 0 marking is in a little bit. Don't start measuring your item all the way to the edge of the meter stick. Go to where the 0 mark is if it's not the edge. A lot of well-made rulers or meter sticks are at the very edge. Some of them aren't. Big mistake I see all the time. Second, this is important. Measure to the last mark you are able to see. Like we talked about in my previous video, different tools have a different level of precision, different numbers of markings. Some are marked every whole number. I've even seen meter sticks marked every 10 centimeters. So you're really just getting a ballpark if that's the case. But go to the last mark on your tool and then guess one digit beyond that. If you can see the 6 marked, is it 6.1 or is it 6.6? Is it closer to the 7? If it's like right before the 7, it would be 6.9. So go to the last mark you see, then guess one digit out beyond that. It's the acceptable rule in the scientific community. All numbers are guesses at some point. The point that we draw that line is one level beyond the last mark on our tool. And the last one, only use metric units. If you're building a cabinet or something, if you're working as a plumber or a craftsman of some kind, you might use inches here in the US. That's okay if that's your field of study, but in the scientific community, and it's my opinion that we should go to the metric system worldwide. There's only 2 countries in the world who don't use metric units, and here in the US, for some reason, we are one of them. So you use metric units. In my classroom, I always tell my students inches, yards, feet, those are cuss words. So let me give you a few practical examples of this and how we would actually use them when we measure. Here I've drawn a paper clip on an accurate but not precise ruler. You can see each individual centimeter marking. There are no other markings than that. Last mark is the whole number, meaning we would guess the 10th. However, in this drawing, I've intentionally drawn it wrong, so you can see here, the edge of our ruler is not the 0. So if this person was trying to measure this way, they're already wrong. They didn't obey rule 1. Start at the 0, not the edge of the ruler. Now, this one is drawn correctly. Drawn at the 0, it's going just a little tiny bit beyond the 2 measurements. So I would say a good example, a good measurement for this would be 2.1 centimeters. 2.2 would be okay. 2.3 would be okay. If you just called it 2 centimeters, you would be accurate, but you would also be wrong because you can see it's a little tiny bit beyond the 2. If you don't communicate that with your guess digit, you are not using the precision rules correctly. You measure to the last mark you see. The last mark we see is this 2 right there. And then you guess one more digit. And so that other second digit, the 10th place, in this case, the 0.1 or the 0.2, that's a guess. That's okay. All numbers are guesses at some point, but in this case, if you just called it 2, you're wrong. It's not 2. I would say 2.0 is wrong too, because it's a little beyond that. 2.1 I would take, 2.2 I would take, 2.3 I would take 2. Your guess might be different than my guess. That's okay. It's a guess digit. It's communicating. It's longer than 2, shorter than 3, a lot closer to 2 than 3. Here's another example that I've drawn. I start at the 0 here. Start at the 0. And then this line goes all the way to 7.6 7.6 marking. It's over 7 and it's under 8, so it's going to be 7 point something. You can see that long tick mark in the middle is the 7.5. It's one tick mark beyond that. So it's a little more than 7.5, which in decimals would be 7.5. That line to me looks like it goes right to the 7.6 marking, not longer, not shorter. If that's the case, in order to use our precision rules, we have to call that 7.60. If we just called it 7.6, again, accurate, good job, not precise. There's a 7.6 marking, and so we don't have a guess digit if we call it 7.6. Since the 7.6 is marked, we need to communicate with our guess digit. Is it longer than that or shorter than that? In this case, special case, it's not longer or shorter, so we need to include that 0. 7.6 and 7.60 are the same accuracy, the same measurement to 2 levels of precision. This 0 says that we have the 7.6 marking on our tool, and so we're guessing it's not longer, not shorter than 7.6. Let me give you a few more examples here. If you'll notice, this arrow ends between the 5 and the 6, so it's in the ballpark of 5.5. Now, if we called it 5.5, we would be accurate, but we wouldn't be precise because there are more markings. This long line right there is the 5.5 marking. And you can see if you look really, really close, it's longer than 5.5, but not quite to the 6th little tick mark. So it's going to be between 5.5 and 5.6. It's just a little bit over the 5.5. It's not quite to the 6th little tick mark there. So my number is going to be 5.5 something. Now the question is, with my guess digit, is it closer to the 6th tick mark or is it closer to the 5th one? And I think it's about in the middle. So my best guess would be 5.5, because I can see that marking. I need to add a guess digit, 5 centimeters. I'd say it's longer than 5.5. It's shorter than 5.6. Since it's between those two numbers, I had a little bit of wiggle room with my guess. It's not really closer to one than the other. I call it 5.55 centimeters. Make sure you include that unit. Here's a few more examples that are images I pulled off the internet. Go ahead and pause the video. Write down your precise answer to how long this red bar is. No, I'm serious. Pause the video. I'm talking to you. Pause it. Write down your answer. Okay, if you've done that, I'm seeing that this red bar is longer than 2 and shorter than 3. In fact, it's longer than 2.3. That's a little third tick mark there. And shorter than 2.4. That's that tick mark right there. So a good guess would be anywhere between those two things. I could call it 2.35, 2.33, 2.37. Anything in that range is an accurate and precise guess. Now, like I said, it's about 2. That's accurate, but since I'm not using my tick marks, it's not precise. Here's another one. So this one's not anywhere close to 1. It's even short of the 1/2 mark. So it's just past the 3rd tick, and it's before the 4th tick. So this would be a 0.33, 0.32. 0.34. Looks to me like it's closer to the 3rd tick than the 4th tick. So I need to communicate that with my guess digit. But since I can see the 0.3 marking and the 0.4 marking, it's between those two, it's going to be 0.3 something. One last example here. It's not longer or shorter than 4, so it's going to be 4.0. And since we can see where the 4.1 and the 3.9 marking are, we need to go out one more decimal. This is 4.00 centimeters. So those zeros matter. Calling it 4 centimeters, sure, that's accurate, but since it doesn't use our tick marks, it's still wrong. If we didn't have any tick marks in between the 4 and the 5, or between the 3 and the 4, all we just had was 1, 2, 3, 4, 5, 6, then 4.0 would be the most precisely we can answer. But since we have a 4.0 marked, as opposed to 4.1 or 3.9, we have to go out one more level even beyond that. So 4.00 would be the right answer on this. As always, this is Mr. Stu. Keep learning no matter what.